Curiosity, how many people is your first time coming to this event? All right, well, welcome. There's actually a lot of people returning. This is awesome. So first off, I'm going to talk a little bit about sponsors and give a shout out to the people that helped make this happen. So, Brian, you want to come up and do your thing for a sec?
Yeah. So this is my thing. I work for Excella Consulting. We bought the food from Capriati's. It's a sandwich place right around the corner on M Street. I first had them over in Roslyn. Delicious, delicious food. Excella is a technology consulting firm. We do basically three major things. Software development is the main thing that we do. We also do business intelligence, data warehousing, and project and program management. And we look for people all the time in those three areas, especially developers, but what else is new in this area? Also, Mike's going to talk about it as well, but last week, I recognize a couple of faces who were there last week. Excella hosted an OWASP DC little side meeting. We decided to do these training nights where you bring your laptop and it's a hands-on, try to hack the OWASP web go, and then try to fix the software that the vulnerability, fix the vulnerability. Unfortunately, we ran out of time and we didn't get to the fixing part, which is kind of the whole point of it, but maybe next month we'll try to get to that part. So thank you, and thank you for coming to the OWASP.
Thank you, and thanks for the food. I also want to give a shout out to Uber offices, nothing to do with Uber, the car company. They're the people that run the space that we're in. They very, very graciously host us free of charge every month, like clockwork, and they are wonderful, wonderful people. They obviously do like shared offices and rent a small space, so, you know, look them up. They're good.
They don't do the cars.
They don't do the cars. They have nothing to do with the cars. It surprised me, yeah. We're at Uber offices, but it's not actually the offices of Uber. OWASP, for those of you that aren't really familiar with it, just a quick blurb. OWASP is it's a 501c3 organization dedicated to kind of improving the state of software security around the world, or application security, I guess would be the more appropriate term. There's a lot of stuff happening at national level, but there's also a lot of really, really awesome things happening at the local level, where we are right now, having the meetings, a lot of people getting together and talking and doing lectures and just having a good old time. If you haven't seen it before, I highly suggest you go to the OWASP.org site and look it up, look at the projects, look at the tools that they've created, the documentation they put together. It's absolutely awesome. It's a great place to learn. All right, so before we go into this real quick, I just wanted to say, first Wednesday of every month is where you should be. Unless it's August, in case it's the second Wednesday, because everybody else's here is going to be a death holiday. So, sorry. Next, the last last Wednesday of this month is going to be the top 10 training night in Roslyn. You go on to Meetup, you can look that up. It's going to be on April 29th. The next week, the next Wednesday, May 6th, we're going to have Dan Ford, the CISO of Blackphone, the secure mobile device. He's going to come in and talk about smartphone security. So that one is going to be awesome, and I'm really looking forward to it. And I hope everybody shows up to see what's going on. So with no further ado, Mr. President Simic, did I get your name right?
Yep.
Simic? Okay, thank you.
Thank you. Can you guys hear me? Cool. So I want to go ahead and apologize for using the word cyber in a talk.
You're in DC, it's good.
You know, I am in DC, and I did actually give this talk last week in DC at a conference where there was a lot of federal folks there, and it kind of made more sense. But I prefer not to use that word.
Why?
It's just kind of terrible. In terms of, yeah, it's like using synergy in a corporate environment, right? People just don't like it.
Where are you from?
Originally?
Well, right, currently.
Oh, I'm from New York City.
Okay.
So, yeah, so I'm going to be talking about the cyber vulnerabilities of biometrics. This is a little bit of a different talk from your typical OWASP type of thing, because it doesn't necessarily strictly focus on one of the top 10, even though it is biometrics are typically used in and number 2, which is authentication. So without further ado, why am I here? What's this all about? As you know, we're pretty terrible at doing information security. We've been doing physical security for a long time with things like big walls and missile defense systems and such. For a long time, we're pretty good at it. But when it comes to information security, we're pretty bad at it. And that's because, really, it's because the way we currently answer, am I who I say I am, is terrible, right? So the main way that we do that right now is with things like passwords. And I mean, you hear about this all the time, like 1 billion passwords are stolen here, these accounts are hacked, blah, blah, blah. Every time you turn on the news, there's some major breach, and it's usually because we're really terrible at answering that particular question. So these are the top 15 passwords of 2014, excuse me. Actually, if you look at the list of 1,000 most commonly used passwords, 90% of people actively use one of them. So like if you're, for a computer, it's really easy to go through and something 1,000 times or go through that list. So it's pretty terrible. We made certain steps recently, in particular with like 2-factor security. So if you're familiar with like when you log into your Chase Bank account, they send you a text message and you have to punch it in. That's one example. Others are like Google Authenticator or Authy, things like that. They run on your phone where you have the token constantly changing. Those things are cool, but they've also been compromised a bunch of times. This talk is kind of short, so I can actually give a couple of stories and stuff. So a really good example of bypassing 2-factor authentication is I was doing work for a bank a while ago, and they had a breach, right? So they were using 2-factor security for their customers when they tried to go into their bank account and send large transfers, right? So what they would do is, if you're logging into your bank account, you issue a transfer, they send you a text message, you have to punch in the code before it goes through. Well, this guy that got hacked was super rich, right? And like multimillionaire type of guy. And they basically used phishing to get this guy's password, which was pretty easy for them to do. So they got his username and password, but they couldn't get that code off his phone because only he had that phone. So these guys went on one of those websites. They took the guy's LinkedIn picture. They went on one of those websites that make fake IDs, and they made a driver's license of this guy. They had a picture of him, but they also the hacker took his picture, made a license. Basically, they issued him a brand new phone with the same phone number, right? So then they used a username and password, logged in, text message came, right? The guy that got hacked, like his phone just stopped working. He realized it like a couple hours later. But that's like a really creative way of bypassing 2-factor security. It's been done a bunch of different ways. I think last year there was like a hack in Europe where multiple banks 2-factor security got bypassed just through like Android malware. So it's something that's more and more popular as more and more people use it. So if there's incentive for hackers to actually do this, they do. So this brings us to biometrics, right? So biometrics to the rescue. We got retinal scanners, fingerprint readers, facial recognition algorithms. These are all new ways of answering, am I who I say I am? Whenever I do stuff. So in the previous decades, we really only saw this in the movies being used, like James Bond and stuff. But now, like, it's in your iPhone. It's in some of your Android phones, right? It's becoming more and more popular, typically in the form of a fingerprint reader, but still, it's biometrics, right? So we're finally at a point right now where it's feasible for the mass consumer base to have a biometric reader on them at all times to use it for authentication, so we can eliminate passwords. Awesome, right? Well, not so fast. There are a bunch of sophisticated attacks that have been bypassing password-based authentication, two-factor-based authentication for a really long time. So what really makes us think that, me having a fingerprint reader on my phone will do any better, right? So what I really kind of hope everybody takes away from this is that biometrics aren't necessarily a silver bullet when it comes to solving the authentication problem. So existing cyber attacks like a bunch of man-in-the-middle type of vectors, malware, particularly on like Windows machines and Android mobile phones. These are like existing ways that have bypassed other forms of authentication. So they can really do it just as easily for biometrics if we're not careful. So like 75% of employees in this country at least use their mobile phones to access like company email. And overall, combining like your laptops and your mobile devices, there's something like 40% there's a 40% chance that you have some type of malware on your phone or your desktop or whatever. So if it's not you, it's probably like your kid or your wife or something. So let's go over a few ways of doing biometrics the wrong way. So here we have your typical iPhone scenario, or like your Samsung Galaxy S6 scenario, where you've got your phone and you've got a biometric reader on it, right? Typically a fingerprint type of thing. And when you use this form of authentication, you put your finger on the phone, and then the reader basically tells your operating system that's on your phone, yeah, it's the right fingerprint, or no, it's not the right one. Well, the problem with this is the same as with like other stuff. If you have malware on that device, it's really easy for it to just, flip that no to a yes anytime it feels like it, if it has control of the operating system. And that's my favorite picture to use of a hacker. I use it every time because the guy with the keypads.
Yeah.
But yeah, so it's really, really easy for malware to spoof a biometric reader. So this tells us that if you're counting on the operating system to be that, end-all, be-all verifier of biometric data, you're not going to have, much success because malware is pretty rampant and you can't depend on it. It really doesn't make it any more secure than passwords or two-factor tokens. Another example, this is a little bit more complicated. So a lot of biometric solutions, us in the AppSec space, we don't typically see this too much because these types of solutions are usually in like the mission critical enterprise and government sectors. So maybe you guys might, since you're in DC, I don't know. But usually the way these are implemented is you have a biometric reader on a computer that's hooked up to a computer via USB or whatever, or your laptop might have it. And then there's a server somewhere that basically stores everybody's biometric data, right? So the first time you get your laptop, you swipe your finger on it, and then that creates a template of your fingerprint, stores it on the server. And then every time you need to authenticate to some app, you swipe your finger, it recreates that template, verifies it on the server, and then the server returns the data if the verification is successful. This is great. The same thing. So you have man-in-the-middle type of scenarios or malware type of scenarios where if you're able to capture that biometric data, that biometric template, you can use it over and over and over again, right? So one of the really crappy things about biometric security is you can never change your fingerprint, really. Like you can change your password whenever you feel like it. Like if you feel like your password might have been compromised, you just change it, make it stronger. Well, with your fingerprint, if that's your main point of authentication, you're screwed if it ever falls into the wrong hands, right? So if somebody is able to intercept that template data, they can just use it whenever they want, which is a huge issue. Yes?
Does your template data stay the same? I would think that there's enough randomness that if you enrolled your right thumb today, that 2 days from now, and you enrolled, you probably have a different template strength.
Nope. It's the same because they have to be able to recreate it to match it against something, right? So it might be a little bit different, but it works off of like a matching algorithm that's where there's usually a good enough solution. It won't be exactly the same every time you swipe, but it'll be similar enough. Another bad reason for doing this is suddenly you have a really lucrative target on that server, right? Because if you have some system that's like storing tens of thousands of people's biometric data, like that's suddenly really valuable if you're a hacker, right? Like if you can gain that, it's certainly a lot more valuable than like people's passwords, right? Because now you have their actual fingerprint information, and who knows what that person will use that for in the future.
What exactly is stored? Is it an image of the fingerprint, or is it a digital mapping that is converted once you swipe it?
Yeah, it's basically just a bunch of metadata about the ridges on your finger.
It's just metadata.
Yeah, but it's it can be used to recreate a fingerprint.
That's what I was wondering.
That's the main point. Yes.
Maybe you're getting to this, but the way that I've seen the problems that you've described resolved, or at least mitigated, is by the claim that biometrics are supposed to be your form of identification, not authentication.
Yeah, so I'll get to that in a minute. That's a good point. But yeah, I am getting there.
Okay.
So the do's and don'ts, but right now this is the main way that people are using it for both. So encrypt everything, first of all, which is fine. Then you have the whole problem of key management, but that's pretty difficult itself, but still encrypt everything. Don't just depend on biometrics. Do device tagging, do like analytics on the way people typically use things, right? If somebody's, track their behavior, if somebody's always accessing their bank account between the hours of 8 a.m. to 5 p.m. From, the East Coast, and suddenly they're accessing it at, 2 a.m. from Russia, there's a problem there. And then don't just depend on biometrics as the sole authenticator, right? So you should still kind of require multiple factors, such as a password and it, and the request coming from a particular device. So don't do client-side verification, which is like what the iPhone does. Don't store biometric data in a central place. Don't rely on passwords. Sometimes you'll see like biometric readers come out that are used for authentication. And then like they'll say, oh, well, if the reader for some reason isn't working as well as you expect it, there's always a backup password that you can use instead, which kind of defeats the purpose. It's basically like putting a back door with a cheap padlock on Fort Knox and then just using that. So yeah, don't store people's biometric data remotely. That's kind of a core one that I wanted to bring up. So tools to use to not make some of these mistakes. Clearly OWASP, but besides that, there's this new thing that's just kind of becoming whole right now, is this thing called the Fast Identity Online Alliance. And what it is like 150 of the world's biggest companies, including Google, Microsoft, they've come together and they've agreed on a authentication standard. And this standard is meant to eliminate passwords. So, and it has a lot of details in there about how to do biometric-based security. And this is something that's, if you're in the AppSec space, if you're like looking at, you know, application security, if you're looking at like authentication issues, this is something to like start looking at now, because in a couple of years it'll be everywhere. Really, there's only a few companies who use this right now because it's still kind of in the phase of being finalized. But the first big kind of user for this protocol is Microsoft. And then there's also PayPal is actually using it if you have a S6 phone. So it's pretty awesome, pretty detailed. They just released their 1.0 spec like a couple months ago, so it's something that you should definitely check out. So there's a lot of biometric companies doing pilot programs right now because everybody's doing biometrics since everybody's phone has biometrics now. So check those out. Send me an email. I can give you like a list of at least 4 or 5 where you can get like biometric devices for pretty cheap, just to mess around with. This is a little bit technical, but so this is the Fast Identity Online Universal Authentication process, and I made this diagram to kind of simplify the process because it tends to be kind of complicated. But it's pretty similar. So if you're using the Fast Identity Online protocol, when you get a, let's say you get a Samsung Galaxy S6 and you want to use it with your PayPal account, you first have to go through this registration process with PayPal for your biometric verifier. And the way it works is when you use your PayPal app, it goes to, the app goes to the PayPal server and it retrieves back a verification token. And it's just a random string. It gets returned back to your phone, and then every single Galaxy S6 now has a secure execution environment, which is separate from the core operating system, which is key here because Android is full of malware. But so that's the point there. That token goes to a secure execution environment. The secure execution environment creates a public-private key pair for PayPal for your particular account. It signs that token, and then it sends it back. And that execution environment also signs, part of that signature is also a certificate that can get verified on the other end. So once you do that one time, your phone is basically registered with PayPal's app. And then the only way to actually authorize that signing process, which is actually part of the authentication protocol, is to use your fingerprint. So this is really cool. If you're not aware, like biometric companies that are making phones are actually doing this stuff. So even on the iPhone, actually, if you've ever used Apple Pay, anybody? Yeah. So if you've ever used Apple Pay, you tap your finger to your fingerprint reader and you touch it to the credit card machine. Well, what happens there is actually that request never goes into the main iOS operating system. Like when you touch your finger there, your fingerprint gets verified on a separate chip that's separate from the core chip in the device. And then that generates a random token that gets sent to the NFC reader, and then that gets transmitted down to the credit card machine. So that never touches the actual operating system, which is really cool because they've kind of absolved themselves from a lot of risk. And this is the pattern that other companies like Samsung are taking with their fingerprint reader, where the verification is done from the core, away from the operating system. So when you use your PayPal account on your S6, the only way that you can sign that token that gets retrieved from the PayPal server is if it's your fingerprint indeed. So that's really that's the core part of this entire protocol, which is still kind of brand new. Yeah, it's really cool. I love to take any questions.
The same size, separate chip as well?
Yeah.
Since this is a new protocol, what kind of devices are you looking at that support this, have this separate embedded chip security?
Yeah, so the fast identity protocol itself, it works in two different ways. One relies on biometrics and the other doesn't. So a lot of phones nowadays have a secure execution environment, but it's not necessarily biometrically secured. So it can still use that protocol, but clearly it's not as secure as using your fingerprint. But more and more phones are coming out with this. So Qualcomm just announced that their new processors will ship with a secure execution environment. And they're specifically designed to basically just interact with a biometric reader, whatever it may be. So it could be like a voice analyzer or like a separate camera that just talks to that chip so they can do like eye scanning, things like that. But the typical and most usable approach to biometrics is your finger because it doesn't depend on too many like external factors. Yes?
Can you walk through the workflow one more time? So the way I have my PayPal set up, so if when I log in, it will change with my phone, like you said, and ask the code. So this setup here replaces the pinging my phone and then pinging for the fingerprint.
So this is like for the PayPal app on your browser, and like when you actually go to PayPal.com on your computer, and this is also for the PayPal app on your phone. So if you have, I don't know if you have an S6 or anything, but like if you did, the way that it would work with the Fast Identity Online protocol is when you try to log into PayPal, like instead of putting in a password, it would just ask you to swipe your finger. Like it won't even ask you for a password anymore, which is pretty cool. But yeah, to the user, it's all seamless because you don't know really what's going on behind the scenes, but that's kind of what's happening is you go to the PayPal server, retrieve a token, it gets signed by the private key, and then that signature gets verified back on the server again so that it knows that the signature came from that phone. And the only way that you can initialize that signature is if you provide the correct fingerprint. Yes?
In any of the current implementations, is there no, probably not like you said, no instant password, but is there a way to re-verify, or let's say something happens to your hand, you need to find another, use your other one to verify, is there some kind of re-enrollment?
Yeah, so you can enroll as many like fingerprints as you want. And that's up to that's up to the device. You can do toes if you want, but still. But yeah, that's one of the things that the Fast Identity Online spec is kind of still trying to figure out in terms of like, what happens if I get my hand chopped off, right? Or what happens if I just lose my phone? That's even like a more common scenario, I hope. So one of the things that they've kind of been fooling around with, which I completely disagree with, is adding a backup password, which is really stupid. But they're still kind of trying to figure that out. But yeah, we'll see what they do. Yes.
How sensitive is it? I mean, we're talking about losing a hand, but if you have your thumb, we're talking the cut, going down from the top of the thumb to the bottom, would that prevent the user from, we're talking about extreme change in the case of losing a hand, but you're not talking about paper cut or.
Yeah, if you're talking about fingerprint readers, most fingerprint readers, modern ones, they will be able to make that distinction. Like if you get a cut on your finger, like it'll still work. Most modern fingerprint readers can make that distinction. Like a lot of them will not just look at the ridges on your thumb, for example, they'll also look at they'll check whether or not there's a static discharge coming from your finger when you swipe to prevent maybe lifted prints from being used. These things get pretty sophisticated, but at the end of the day, what this protocol really does is it eliminates the likelihood that there's going to be a massive breach, right? So like, if I'm a hacker and I hack into some server and I get everybody's passwords, that's really useful. But if I have to go from individual phone to individual phone to individual phone to get something, I'm much less likely to do that because that's a lot of work for not so much reward.
As long as there's not a centralized repository.
Correct. And that the way that this protocol works is your fingerprint information never leaves your device. So it's never stored anywhere. Even the verification server that I mentioned earlier, it only holds public keys. So like even if it gets compromised, you never have to worry about it because you can just revoke those.
So just to let everybody know, I put a thin layer of wax on the outside of these cups. I'm kind of curious, if I am, if you want to divorce or create a separation here, and I think maybe if I describe this, we'll be talking about the same thing. But, with passwords on servers, we basically hash the password.
Mm-hmm.
We've segregated that responsibility by separating. We don't actually store passwords on the server. So we couldn't compromise your other accounts because all we have is the hash, right? And we solve that hash, right? So we do something to basically create it and make it unique also, so somebody can't use the same algorithm and just try to link over and figure it all out, right? In this case, we have biometric data. Now it occurs to me that those ridges could just be hashed, right? So why store it at all in a central location? I mean, if you can hash it. Now, I mean, granted, you need to salt it some way. You could get that as in the form of a key or something like that almost from the server and pull it to the phone and use that algorithm and hash it. So is that a viable solution? Is that
So here's the thing.
what's being described here?
Every time you swipe your finger on a biometric reader, for example, if we're talking about fingerprint data in particular, the template that gets created is slightly different, right? So if you hash it, the next time you swipe your finger, it's going to be a completely separate, different hash, right? So there's an issue there because what happens when you're comparing fingerprint data is you're doing like a good enough comparison, not an exact match.
Okay, so what if we have a heuristic that can estimate within some range that provides?
Yes, but if you're talking about hashing, you can have a very small difference and the hash would be completely different.
Not if your heuristic is, okay. I'm not gonna.
So to get to this point, image matching on Google and services like Tiny or however you want to pronounce it, the way they work is they reduce data. I'm not familiar with fingerprinting, so I'm just asking to see if this is a suitable analogy. They reduce the image down to something that would be considered a quote-unquote good enough comparable data, so to speak, whereby the odds of having two extremely reduced images will still be so far apart that if you're finding a match for an image that you didn't actually submit, or if you submitted a different image and you find a match, like that's really remote. Does it not stand to reason that that same process would be happening here, whereby you get an approximation, whereby you get some data from swiping your fingerprint, and then that data is reduced to something that still can be used for comparisons, but allows for slight variations, and then hashing that data instead?
Yes, so that's just, that part of the process strictly occurs on the phone.
Yeah.
Right? So yeah, that's fine. And different fingerprint readers do that in different ways. And that's perfectly cool. The thing is about the Fast Identity Online in particular, their authentication protocol is they don't care about what kind of biometric you're using.
Yeah.
As long as it fits, as long as it's reasonably secure. So it could be sometimes a lot of people are saying that biometrics aren't fingerprints or retina scanners or voice analyzers. They're just the way you type or different behavioral types of things. So certainly the way that you do the biometric doesn't really matter as much. What matters is that the verification happens separately from the operating system, and that biometric data is never stored on a server. Because that's when, you know, sure, we store passwords, we hash them and salt them on servers right now, but really, like a lot of people still don't, right? And what happens is, in particular with passwords, you know, people use terrible ones or they reuse them all over the place. So if I'm using some random, if I'm like signed into some random blog or something, I'm using the same password as I am for my Chase account. You know, that guy who's got a box in his basement running PHP, running his PHP-based blog, he probably isn't hashing and salting my password. So I only have to compromise it at that one place to use it everywhere else. Yes?
So you mentioned the fingerprint being maintained or being processed entirely separate from the operating system. Is there any interaction between that other chip on the phone and the rest of the phone, whether it's, let me just ask the question. Is there any interaction between that chip and the rest of the phone that could be exploited? And separately, would there be an opportunity to exploit the communication between the phone and the NFC reader?
Okay, so the question is if there is interaction between the phone's main operating system chip and the secure element chip, and whether or not that can be compromised in some way, right?
Yeah.
So typically, the only communication that those have, for the communication with the main chip to the secure element chip, it basically just says, I need you to authenticate. That's typically it. And then it gets back a signed message. Now that signed message, it cannot be read by that operating system. It cannot, the only place that can verify it is that remote server. So at that point, it's basically using your operating system and the fact that your phone has an internet connection, a data connection, as an antenna to that server where the verification actually occurs. So probably not. Yes?
So the only input you're saying is supported is authenticate this user essentially. Like if it was it would be a very binary operation then. Like just literally the only input coming from the OS to the secure environment would be to initialize the authentication process.
Yeah, so I should correct myself there, sorry. The message is, I need you to authenticate this user, and here is the random string token that you need to sign.
Okay.
And then.
So there is still an input then?
Yeah.
Okay.
Yes.
I mean, back in the day, you just mod out a PlayStation, you can't just do that with that chip.
No, it is possible. It's very much possible. And smart people are going to find ways around this. But the core point of this whole thing is to eliminate that chance of there being a major breach where everybody's data gets stolen at once. Yes.
You may have talked about this. Does decrypt the data on the phone?
Not that I'm aware of yet.
Okay.
Because that data is typically stored in, the main data of the phone. So if you have root access, it's, kind of.
I wasn't sure if the primary mechanism of operation would allow for perhaps a decryption key to be passed back to the OS in order for the OS to then not the OS, for the phone, back to the phone, so the phone can then decrypt the contents of the flash memory.
The issue is then if the OS is rooted, right, and you're passing it decryption keys, it's kind of, so you basically, the way that this protocol is designed, and rightfully so, I think, is it completely assumes that your OS is compromised, already. So I think that's the way to go, really. Yes?
So you said the digital signature is actually created within the chip itself, the chip, and that
and then it's sent over to the voice over.
Mhm.
And then after that, then the voice over would say, this guy is who he says he is, and then.
Yeah. And it'll return back whatever information you requested or process a payment or whatever. But yeah, it's just to take responsibility away from your operating system in your hand or on your desktop, because chances are it's compromised. Yes.
So you mentioned voice as being an alternative signature to, thumbprint or something. What other biometric signatures are being considered?
So voice, retina scanners, facial recognition algorithms, so they'll make you hold your phone in front of your face and it'll scan your face and make sure it's you. They have like different uses for different scenarios. Like if I'm in a loud bar, like I'm not gonna be using my voice, I'm gonna use something like my fingerprint. Or if I'm in a dark place, using my camera isn't really feasible. So they all have their advantages and disadvantages. Like the government sector, they'll use like retina scanners, right, because they can. But it's in a controlled environment. Yes.
I'm trying to understand. Is this similar to a TPM chip in the PC?
Yes.
But for a phone?
Yeah.
Okay.
Yeah. So.
What is that? Oh.
So yeah, I think the new Microsoft laptops are coming with it, right? Like with the Trusted Cloud, and they're coming with. It was just announced like a week or two ago that they're gonna. Like all laptops are going to basically support this protocol. It's pretty cool. Anybody else? So I'm gonna stick around if you have any questions. Feel free to ask. Thank you, guys.
Thank you. That was awesome. All right, so that is it. Hope to see you next month. If any of you decide that you need to, speak at OWASP for whatever reason, let me know. We're always on the lookout for speakers. That's it.
Yeah.
Thanks.
You got the cover slide again?
Yeah.
Do you want to notate where people can reach you as well?
Yeah.